And welcome back to the final homework helper video for Math 1 in Unit 3. This is Lesson 6, Another Day. And so jumping right in, we're looking and we're saying solve these equations. These are the ones that you guys have enjoyed the most because it reminds you of your wonderful middle school days. But we go through and we say, all right, let's just go solve these. We're going to divide both sides by 2.5. When we do that, I guess I'll show that step. Please use calculator. We're going to get x is equal to 16. Don't leave it as 40 over 2.5. That'd be insane. We get here to the next one. We're just going to add 12 to both sides. We're going to get n is equal to 41. Back here, we're going to subtract 15. We're going to get 7t. 7t is equal to 21. Divide both sides by 3. So we get, divide both sides by 7 to get 3. And have yourself a day. We're then going to go down and look at problem 5. The equation 12.5t plus 500 is equal to 3,500 was created in connection to the following situation. Jamie is considering a job opportunity that's offering a sign-in bonus of $500 and $12.5 per hour. He's hoping to earn $3,500 before he returns to school in the fall. We're looking to see, all right, let's just go through and solve this right off the bat. We go through using the original equation that's provided up here. You're going to subtract 500 from both sides. You get 12.5t is equal to 3,000. Divide both sides by 12.5. What that'll do is give you t is equal to 240 hours worth of work is what that means. That's how many hours he needs to put in order to reach his goal of 3,500. It then asks us if Jamie can work 40 hours per week, how many weeks will it take him to achieve his goal? We need to take the 240 we just solved for and divide it by 40 hours in a week. And this will take him 6 weeks. So if his goal is to have $3,500 in his account based off of that job opportunity, he could hit it or reach it in 6 weeks. Awesome. So moving on to problem 8. I did draw in some things, sorry, just to show this. Once again, problem 6 here, sorry, moving to problem 6, is problem 8 uses some information from 6. So it really only uses f of x and g of x, which are these first two equations. So I went through and I graphed these preemptively on the next coordinate plane. So when I did that, I end up with our f of x equaling 2x plus 7 there in pink, and then g of x is equal to 2x minus 4 in purple, the lower of the two. Problem 8 asks us, explain how g of x can be translated to be the same as f of x. So it's asking, how far would we have to translate or do a vertical shift for the moment, the purple line, to get it to sit on the pink line? So really it's just asking, how far do I have to move this point here to get it to sit on this point here? And our answer for that is we're going to have to shift up 11 spots, places, whatever it is that you want to call it. So cool. That's all that's asking for. This next piece, I did a little bit of background work as well, just because I wanted to have some points set up. So use graph of p of x in the descriptions to graph j of x and r of x on the same coordinate plane. I went through and p of x was already there. I just added some points just to make life a little bit easier. It asks us j of x, which let's go through and do this. We'll do j of x will be orange. And we'll use some color. I don't use green. Some Miami hurricane colors. And if j of x is saying up 5 units, you're just taking every point that we have there and shifting it up 5. So I'm just going to use the 3 middle ones. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. To get there. Come on. And then we're just going to go through and connect them. So, boom. I might call that j of x, just in case there's something wrong. For R of X, it's asking us to shift down 9. So we're going down. Just take your points, lower 9. 1, 2, 9, 9, 9. All right. 1, 2, 3, 4, yeah. And go down and grab that. So we've got R of X. These vertical shifts just mean that every point in the original function is getting raised or lowered depending on what's there. If it's an up, it's a plus. If it's a down, it's a minus. Awesome. Problem 10 is not needed. Problem 11. If a graph of a function is translated either up or down to create a new function, how would this translation connect with equations of the two functions? Just so that we can go through and say, this one is just, actually we just kind of covered this, is we're just saying we're either adding or subtracting by some amount to get those two functions to be equivalent to each other. If we are shifting everything up, we're saying it's plus some units, some number units. If we're shifting it down, it's minus some amount of units. And that's all that's being asked for that problem. It's just describing what's going on. We don't have anything on the next page. For problem 14, it's asking us to answer all these different pieces in here. So the graph is a model for an amount of gasoline in a tank of a large cargo truck during a day of work. So it asks us for our domain. How far left to how far right do we go? And if we look, we start at 0, great, and we go all the way to 11, including both of those points. So when I go through and I write down what's my domain and whatnot, I'm going to say starts at 0, goes to 11, both are included. My range, oops, got to think a little bit here, come on, is what is my lowest point? My lowest point here is I have to think up and down. My lowest point for my graph is sitting right at 12. The highest point is sitting at 40, with both of those being included. So I'm going to go through and I'm going to say, I said the low was 12, and the high was 40. We don't care about what the x values are. I only care about the y's for the range. When we go through and we look at, we'll do the max here. Let's switch our colors up because I don't care for the green. Our maximum point we want to look at, and we say, oh, that's 0, 40. All right, both numbers that we've used before, but this is a point, so we'll put parentheses. Our minimum is going to end up being 11, 12. This is our lowest point that we see on our graph. Our x-intercept, we really don't have it because it looks like it's coming down this direction, but doesn't actually get there, and we're not going to go through and extrapolate and make up numbers. Just not going to do it. So we get that as an x-intercept. We also go back and we say, oh, when is it increasing? It never is. We're going through and it's never has a positive slope. So in here, we also say there's nothing for us to put. Our y-intercept is going to be 0, 40. It's the same, oddly in this situation, is the same as what our maximum was. It was, he started with the most amount of gas that he was going to have all day, because as soon as he starts driving, his gas goes down. Now, decreasing, we're going to talk to this one out loud. When we go through, in previous videos, I've done this with a highlighter. I'm going to go through and I'm going to say, we're going down, 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 down. Oh, we're no longer going down. We plateaued. But then we go down, 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 down to there. Great. So when we're going through and we're talking about the intervals for this, we're saying from 0 to 4, we were decreasing. From 5 to 11, we were decreasing. But there's that gap where it technically isn't decreasing. It's not increasing, but it certainly isn't decreasing. So I'm going to say from 0 to, I already forgot what I just said. Luckily, I think I have this one down somewhere. From 0 to 4. And that's hard brackets. And from 5 to 11, we're decreasing. Now, there's one more part of this problem, which I think got cut off, maybe on the other part of the page, which I just want to make sure that we're reading it. What is happening during the time interval from 4 to 5 hours? Why might this be the case? So I'm going to answer this problem. It's on the new page for me. It's probably squeezed at the bottom for you guys. Is that what's happening from 4 to 5? What's happening where we're not highlighting pink here? My best guess is they stopped for lunch or something. They stopped driving. They pulled over at a rest stop, or they were doing something where they were stationary. The engine wasn't running, and therefore they weren't burning gas. Cool. All right. That is it for today's homework helper. If you have any questions about any of this, please make sure to go see your teacher later this week.